Assalamualaikum and hi everyone. So in this video we are still in chapter 1.1 reaction rate, but I will teach you the second method to determine the order of reaction involving single reactant, and the method is half-life based on the graph of concentration against time. That means you can determine the order of reaction from the half-life graph. Okay, that means in this video you will need a graph paper. Okay, so half-life method. Okay, so half-life method tips dia adalah based on the graph of concentration versus time. Okay, that's mean if you want to determine the order of reaction by using half-life method, you have to plot a graph of concentration versus time. Okay, sebab graph half-life memang concentration versus time. Concentration will be the y-axis and the time will be your x-axis. So you can recall back graph half-life, okay, dekat zero order, first order and second order dekat sini. So this y-axis here is actually adalah concentration, okay, and the x-axis adalah time, okay. So semua graph ni adalah concentration versus time. Okay, so that's why kalau kamu nak determine order of reaction by using half-life graph, you have to plot a graph of concentration versus time graph. Okay, so let us have a look at example. So in this example, N2O5 decomposed to NO2 and O2. Okay, and the data given ada dekat sini. Okay, so as you can see, time here is in minutes. Okay, and the concentration of N2O5 ada exponent -4. That means, let's say for this example, the concentration of N2O5 is actually 180 exponent -4 molar. Okay. Right, when you do your calculation, don't forget to include exponent -4 in your calculation lah. Okay, and then how do I know this is concentration? Because of the square bracket here. Okay, so the square bracket means concentration. Okay, so soalan clearly ask you to plot a graph of concentration versus time and determine the order of reaction. Okay, so first thing you have to plot concentration N2O5 versus time. So concentration N2O5 will be your y-axis, time will be your x-axis. Okay. So saya pun plot lah graph di atas kertas graph. Okay, you will need a graph paper bila soalan suruh plot. Okay, alright. So dah plot dah graph. Okay, so please make sure when you plot a graph, you need to label your y-axis together with the unit. Okay, and the x-axis with the unit. Okay, and don't forget exponent -4 kena tulis juga, and the title. Okay, so this is the graph of concentration N2O5 versus time. Okay, and then saya pun plot lah all the values tu, and it turns out saya dapat curve. Okay, so bila dapat curve, okay, dalam fikiran saya, oh, half-life graph yang curve belongs to zero order ke, first order ke, second order. Okay, kalau tak ingat, that means you have to refer back to notes yang inilah. Okay, so kita tengok balik. Kalau kita punya graph curve, that means order of reaction can be first order or second order lah. Zero order dah out dah. Okay, but how to differentiate sama ada the graph is first order or second order? Okay, so we have to determine ni, half-life ni. Okay, kita kena cari half-life dia. Kita nak tengok trend half-life dia. Okay, so let's say lah trend of your half-life tu, kat sini kan saya ada bagi summary, trend of half-life tu sama. That means first half-life and second half-life, the value is the same. For example, 60 minit. Second half-life pun 60 minit. Okay, so that means dia adalah first order reaction lah. Okay, tapi kalau lah kamu determine the first half-life is 60 minit, the second half-life adalah 120 minit, that means that graph adalah second order reaction punya graph. Okay, so jom kita cari half-life satu-satu. Okay, so to determine half-life from the graph, okay, kita tengok the initial concentration of N2O5. Okay, so the initial concentration of N2O5 at time 0 ni lah, okay, adalah 180 exponent -4 molar. Okay, so maksudnya dekat sini lah 180 ni adalah initial. So half of the initial concentration adalah 90 lah, sebab 180 divide 2 is 90 kan. Okay, so kita kena cari where 90 dekat sini. Okay, so if over here is 80, that means dekat sini adalah 90 lah dia punya concentration dia. So let me label this as 90, and then I need to macam buat dot sehinggalah sampai ke garisan graf kita and then tarik dia turun. Okay, so saya guna color yang berbeza so that you can see that clearly. Okay, and then we have to determine the first half-life. Okay, half-life adalah time taken for the concentration of N2O5 ni untuk reduce jadi half. Okay, so the time taken is from 0 until 20. So the first half-life adalah 20 minutes lah in this case. Okay, sebab unit dia minutes. Okay, so kita dah dapat the first half-life. So next, kita kena determine the second half-life. Okay, so second half-life pula, kalau dah punya concentration 90, half of the 90, that's mean 45. Okay, so where is 45? This one dekat sini 50. So 45 is should be around here lah. Okay, and then tarik sampailah ke graf kita. Okay, lari sikit lah. And then tarik dia turun. Okay, so this is berapa nilai ni? This one around 43 lah. Okay. Alright, so kalau itu 43, so we have to determine the second half-life. Second half-life daripada 20 ni pergi ke 43 ni berapa dia punya difference. Okay. So kalau kita calculate, so T half equal to 43 minus 20 is approximately 23 lah kan. Okay, 23 minutes. Okay, so now we can see the trend for first half-life and second half-life. Okay, so first half-life, the time taken is 20 minutes. Okay, second half-life is 23 minutes. So almost the same lah. Okay, so maksudnya we can say that first half-life and second half-life is the same. Okay, so bila the same, so that is a characteristic for first order reaction. Okay, so ingat balik yang graf dekat sini. Okay, so kalau nilai dia sama, so that's mean first order reaction. Okay, so now we can conclude that this reaction is a first order reaction. Okay, so you should write something lah dekat bawah ni untuk explain your answer. So saya cakap based on the graph, the half-life is a constant, okay, and does not depend on the initial concentration of N2O5. Okay, therefore the reaction is a first order reaction. Okay, so half-life dia constant. Ini yang penting lah sebab dia 20 minit, 23 minit, kita assume dia sama lah. Okay, and does not depend on the initial concentration of N2O5 ni sebab kalau formula half-life untuk first order, T half equal to ln 2 over K. So as you can see from this formula of half-life, okay, tak ada pun concentration apa-apa dalam ni kan, concentration N2O5 lah in this case, tak ada pun dalam formula half-life untuk first order. So that's why dia cakap does not depend on the concentration of N2O5. Okay, so therefore the reaction is first order reaction. Okay, so next question, determine the rate constant K. Okay, so nak determine rate constant K, usually kalau dia suruh plot graph, maksudnya kita akan guna data daripada graph lah untuk cari jawapan yang seterusnya. Okay, so the rate constant K can be determined by using half-life punya formula. Okay, so kita tulis balik half-life formula for first order, T half equal to ln 2 over K. Okay, hantu satu kaki. K yang kita nak cari, so rearrange ln 2 sepatutnya bahagi dengan half-life lah. T half tu adalah half-life. Okay, so ln 2 we don't have to worry because dia memang constant. Okay, half-life kita adalah 20 minutes. Okay, so we need to divide with 20 minutes. And it turns out my value of K is 0.03466 per minute. Okay, so unit dia jadi per minute lah sebab kita bahagi dengan minit kan. Okay, alright, so inilah jawapan saya untuk rate constant kita. Okay, so basically dah siap lah untuk this example. Okay, so ingat salah satu cara untuk determine order of reaction adalah dengan menggunakan half-life graph. Tapi another tips, okay, half-life graph ni kita akan guna kalau soalan minta sahaja. For example, if the question macam soalan ni lah very clear, dia minta concentration versus time punya graph, then baru buat. Okay, Kalau soalan tak cakap apa-apa, dia just cakap by using a graph, determine the order of reaction. Usually, kamu kena buat linear graph method. Okay, so itu yang kita akan belajar in the next video. Thank you. Bye-bye.